Applications of exponential growth and decay. So here on this part we have exponential model, and that is a equal to a sub 0 times e power k times t. A sub 0 is initial amount at time t equal to 0. K is rate of growth or decay as a decimal. T is time in given units. A is amount at any time t. So based on this function that we have here, f of t, again t is time, this is equal to a sub 0 times e power k times t. When k is greater than 0, so this one here, port A, we're going to have growth. If k less than 0, we will have decay. So in port A, we have growth. That means from left to right, this graph is increasing. That's why we have growth. And here, part B, from left to right, this graph decreasing. Because of that, here we have decay. This example is for when k is greater than 0. So we're going to have growth. The population in thousands of CDT years after 1970 is modeled by A equal to 45 times E power is 0.032 times T. Part A, what was the population in 2005? So here we have 1970 and here we have 2005. Subtracting these two, we're going to have T equal to 35. So using A equal to A sub 0 E power K times T, we can find the answer. So T 35. And here using what was given on that part, so we have 45 times E power 0.032 times 35. Running to one decimal place, here answer is 137.9, and this is in thousand. Part B, when will the population double? Based on what was given, A sub 0 is equal to 45, so double this number, we're going to have 90,000. Let A equal to 90, so what we're going to have for A equal to A sub 0 E power k times t, we're going to have 90 equal to 45 times E power 0.032 times t. Now divide by 45 to solve for t. So here we have 2 equal to E power 0.032 times t. So here we have E. I'm going to use natural log on both sides. Here on this part we have unspoken base E. So we can cancel this part. So that means we can have natural log 2 equal to 0.032 times t. Then divide by 0.032 both sides to solve for t. So here we have natural log 2 over 0.032. It is equal to t. Running to two decimal place, t is 21.66. So what was given, we had 1970. And after 21 years, that means here on this part we have year 1991. So in 1991, the population will double. When an amount of money, P sub 0, is invested at interest rate K, compounded continuously, interest is computed every instant and added to the original amount, the balance P of t after t years is given by exponential growth model. P of t equal to P sub 0 times E power K times t. Port A, suppose that $3,000 is invested and grows to $44,754.75 in 5 years. Find the exponential growth function. So based on what is given, P sub 0 is equal to 30,000. P of t is equal to $44,754.75. T is 5 years. We have to find K. So here we have $44,754.75 equal to $30,000 times e power k times 5. Now solving for k, we have to divide by 30,000 both sides. So we have 1.491825 equal to e power 5 times k. So here we have e. I'm going to use natural log on both sides. So right side here we have unspoken base e. We can cancel this part. So we're going to have 5k on right side. Now divide by 5. So use calculator and round to 2 decimal place. K is 0.08. So our exponential growth function is p of t equal to 30,000 times e power k. We have 0.08. Then multiply by t. So this is our function. What is the doubling time? We're going to use part A. In part A, P sub 0 is equal to 30,000, and doubling that initial number, we're going to have P of t equal to 60,000. And K is 0.08. We have to find t, so 60,000 equal to 30,000 times e power is 0.08 times t. So divide both sides by 30,000. So we have 2 equal to e power 0.08 times t. Now use natural log on both sides. So this way we can cancel this natural log because of having unspoken base e. The natural log 2 is equal to 0.08 times t. Then next step, divide by 0.08. T is equal to natural log 2 divided by 0.08. Rounding to 2 decimal place, we have 8.66. So here answer is 8.66 years. Now here on this part, this example is for decay, and that is when k is less than 0. An element decays according to the model A equal to 750 times e power is negative 0.0139 times t, where A is the amount of the substance remaining after t days. Part A, find the amount remaining after 14 days. So here on this part t is equal to 14, and based on this function that was given, A is equal to 750 times e power negative 0.0139 times t is 14. Using calculator, rounding to 2 decimal place, answer is 617.37, and this is in grams. Part B, find the half-life of this substance. So if we start with 750 grams, half of that number is 375. So A is equal to 375 grams, and then solve for t. So here we have 375 equal to 750 times e power negative 0.0139 times t. Solving for t, we have to divide both sides by 750. So here we have 1 over 2 is equal to e power negative 0.0139 times t, and then use natural log on both sides. So we have natural log 1 over 2 is equal to natural log e power . Now we can cancel this part because of having unspoken base e. So we have natural log 1 over 2 equal to negative 0.0139 times t, then divide by negative 0.0139 both sides. So I rounded to 4 decimal place, 49.8667. So I'm going to run this again to 2 decimal place, so we have 49.87 days. Carbon-14 decays exponentially with half-life of approximately 5,715 years. Carbon dating is useful for artifacts or fossils up to 80,000 years old. Older objects do not have enough carbon-14 left to determine age accurately. Part A used the information given to determine the exponential model for carbon-14. So we don't know initial amount, but a sub 0 divides out. So we're going to solve for k. What we have here, 1 over 2 times a sub 0, that is equal to a sub 0 times e power k. T is 5,715 divided by a sub 0 both sides. So we have 1 over 2 is equal to e power 5,715 times k. Now use natural log on both sides. So this part cancels. So we have natural log 1 over 2 equal to 5,715 times k. Now divide by 5,715 both sides. Rounding to 6 decimal place, k is negative 0.000121. So a is equal to a sub 0 e power negative 0.000121 times t. So this is our exponential function. In 1947, earthenware jars containing what are known as the Dead Sea Scrolls were found by an Arab Bedouin herdsman. Analysis indicated that the scroll wrappings contained 76% of their original carbon-14. Estimate the age of the Dead Sea Scrolls. So a sub 0 is initial amount. A is equal to 76% of a sub 0. K from part A is negative 0.000121, and we have to find t. So here we have 76% of a sub 0 equal to a sub 0 times e power negative 0.000121 times t. Divide both sides by a sub 0, so we have 0.76 equal to e power negative 0.000121 times t. Use natural log on both sides. So natural log 0.76, that is equal to natural log e power negative 0.000121 times t. So this way we can cancel this part. And then we have natural log 0.76 is equal to negative 0.000121 times t. Now divide both sides by negative 0.000121. So rounding to 2 decimal place, t is 2268.07. What that means, here we have 2,268 years old. So this is our final answer, and note that here we have time, we cannot have negative answer, so this is positive.